So we talked about elements and we talked about atoms and how all of those things are arranged or organized. Um, we've made what's called the periodic table. Okay. So our learning target for today is I will use the periodic table as a model to predict the relative properties of elements. The periodic table is a table arrangement of chemical elements organized based on their atomic number, electron configuration, and recurring chemical properties. Okay, we're going to talk about some of these things and some of them we're not. Okay, so each box on the table of elements contains four things. The first is the atomic number. That's the number that's above or at the top of the box. The symbol, which is sort of an abbreviation of the element name, the atomic mass, which is at the bottom, and then the element name, okay, which is also here. So if you look, we have carbon, the symbol is C. It's number 6 on the periodic table, and it has a mass of 12.01. Okay. Periodic table organizes things in groups and periods. Groups are vertical columns, so they go up and down. They have similar properties. They react similar in chemical reactions. They show charges for ions, and they show valence electrons. All of these we'll get to in other lessons. In the periods go side to side. They're horizontal rows. Each row represents an energy level. Again, we'll talk about that in the near future. The number of electrons that fit in an energy level are equal to the number of elements in that row. Again, we'll talk about that later. Okay. The groups in the periodic table are called families, and the families are groups in the periodic table that have similar properties and reactivity. Chemical families tend to be associated with the vertical columns on the periodic table. However, they can include the rows. So group 1 are the alkali metals. Group 2 is the alkaline earths. Groups 3 through 12 are the transition metals. Group 17 is the halogens. Group 18 is the noble gases. Period 6, that's in the two rows that are at the bottom, are the lanthanides and the actinides. The periodic table separates the elements into 3 types of classes. You have the metals, the non-metals, and the metalloids. Okay? Metals are elements that are lustrous, so they're shiny, malleable, they can be shaped, ductile. They're good conductors of heat and electricity. They're mostly solid at room temperature, except for mercury, which is the only metal that is liquid at room temperature. Okay, so what I'd like for you to do is pause and color all of the metals in your periodic table. I want you to color them blue, please. Okay, non-metals are dull. They're not shiny. They're brittle. They're non-conductors. And then some are solid, but many of them are gases. Bromine's the only one that's a liquid at room temperature. Okay. So again, I want you to pause and I want you to color all of the non-metals, including hydrogen, which is way over here. I want you to color those yellow. Okay. Metalloids, an element that tends to have properties that are similar to both metals and non-metals. They separate the metals from the non-metals. All of them are solid. They are not shiny, and they kind of conduct heat and electricity, but kind of not. They're not very good at it. Okay, so again, hit pause and color in purple your metalloids on your periodic table. Okay, and then the last one is that there are some special groupings. The main group of elements are the groups that are 1, 2, and then 13 through 18. So you can see this is 1 and 2, and then these are 13 through 18. Those are just they're like the main elements. Okay. And then there's the transition metals, which are that set in between that kind of separate the two main group elements. Okay. So now you should be able to use the periodic table as a model to predict the relative properties of elements.